There's a formula that exists that led to the advancement of several tech companies. These companies have gone on to electrify their cars on the road and make them autonomous, map the signals of the human brain, and integrate computer chips allowing for a neural computer connection, and even reignited the space race after years of dormancy after the great Apollo program of the last century. That formula is known as the five principles. In order to stay locked onto the signals in his companies, Elon frequently references the five principles as a way to approach hard engineering problems. The principles are question every requirement, delete, optimize, make it go faster, and automate. Number one, question every requirement. Humans have been accumulating knowledge at this point for millennia. We have discovered countless physical concepts by experimentation and innovation. However, we have also built up a world to tie everything into a neat bow that sometimes fails to serve in the ways we need it. For example, in the early days of SpaceX, Elon was frustrated by how expensive the Merlin engine was compared to the Tesla engine, despite being lighter by weight. The answer was that the Merlin engine was subject to countless of NASA and military specifications that the Tesla engine wasn't, thus making it more difficult to produce to be compliant. To combat this, Elon urged all his employees to know every detail of those specs down to the exact person who approved them, so they could challenge them and ask why it is necessary. If they couldn't provide a good answer, then it should not remain. Number two, delete. There's another saying that is common among Elon's companies, and that's that the best part is no part. SpaceX and Tesla employees are urged to delete as much as possible, refining components to the most basic function by eliminating parts. If you aren't adding 10% back in, then you aren't deleting enough. The point is that by actually attempting to delete waste from your process, whether it's unnecessary parts, transportation, overproduction, unnecessary operations, or motion, you are able to see the component or the process for what it really is, and thus what it actually requires. Sometimes you will push too far and need to add something back in, but that's good. It means you've identified an area that is integral to the system. Number three, optimize. Once you have reduced your system down to only the most necessary components, make what's there better. This might look like making a cleaning tank that is only big enough for one part that is positioned directly before a welding booth, such that the welder does not need to move to get to the next part. It may look like taking a die change that took 1 hour down to 30 seconds by changing the die design, clamping scheme, implementing power tools, and organizing a quick change team to be summoned whenever a change is necessary. Optimization may look like consolidating all customer information to one sheet, so there is no need to hop between different spreadsheets and documents. Whatever it may look like, it is the natural continuation of the deletion and allows for a streamlined flow. Number four, make it go faster. A process that has been through stringent questioning of their requirements, deletion of unnecessary processes or parts, and optimized for the current production demand will inevitably face new challenges when production demand ramps up. In the manufacturing context, good engineers will design their process to meet customer demand, nothing more and nothing less. This minimizes the amount of money tied up in inventory and ensures the customers are receiving the products when they were told they would. Making a process go faster, derived from increased customer demand, means your system will be pushed until it breaks. What may have worked for one production run capacity may not keep up during this one. So you must repeat steps 1 through 3 to eliminate waste that holds you back from making this new target. Number 5, automate. The last step is automate. This is the last step because it only comes once your part or process or system is so refined that it is simple enough to convey to a machine. If the system is riddled with waste and flaws, then you will only magnify mistakes when automating. A process is only as good as it is simple. Robots and machines can be programmed for complex routines, but they cannot possibly be prepped for every possible scenario. So it is critical to remove any variation, waste, or unnecessary processing from your system. Elon Musk has been able to build these tech giants not because he immediately knew how to manufacture, but because he went through the trials and failures that he learned from. In one instance, at Tesla, they automated an entire production line before attempting the preceding steps, and it ended disastrously. The robots and machines were the bottleneck because their inputs were too numerous and thus couldn't be expected to produce a reliable output. While this framework is intended to make manufacturing processes as best as they can be, you can also apply it to any system in your life. Once you have a clear reason for everything you do, once you have removed all the noise, once you have made what you need to do easy, and once you have pushed yourself to the limits, are you then able to take those tasks and automate them? Maybe the goal is as simple as setting up an automated investment for your personal finances. Or maybe the goal is an effective workout routine that trains the whole body in the least amount of time. Whatever your goal may be, just keep the 5 principles in mind. Question every requirement, delete, optimize, make it go faster, and automate. This video was a lot of fun because it allowed me to see how Elon Musk views processes. In some ways, there are some similarities to the ways I approach problems at work with Kaizen. In other ways, I have a new way of thinking of the actions I am performing and why. I hope you guys enjoyed this video. It was a lot of fun to make. I'll see you guys in the next one.